Good evening, everyone. Welcome to another CNC router mixture. Um, we do these every Tuesday night at 7 p.m. There's a link in the comments if you'd like to join us, and we'd love to have you live on Zoom with us. Um, so I'm just going to spend a moment to make sure I've got the post out to those folks uh, that may have been wondering whether we were going to do this today, because I wasn't certain either. As you can tell from my voice, uh, I have not been feeling the greatest. So, um, let's see. All right. So, anyway, glad I got Milo here. How you doing, Milo? I can't hear you, Milo. It doesn't show that you're muted, but I'm not hearing you.
How about how about now?
Got you now.
Too many buttons.
Well,
Recovered from last week?
not even close.
I was gonna say I thought I heard a little bit of residue.
Yeah, it's more than just a little. Um, Whatever was going around my grandson's daycare just wiped out the whole family.
Oh
It,
wow.
yeah, it's not corona, thankfully. It was some sort of cold or flu, and it just bam took me down anyway. Been 10 days, 11 days, like that. So anyway,
Yeah, they put COVID out there and it was everything that happened was COVID. Well, now they found out, oh, there's still other diseases or other viruses.
yep, and they're nasty. So uh, be prepared. Keep your over-the-counter stuff right handy, and take zinc tablets early on. Maybe it'll lessen things for you.
Yeah, heard what vitamin C is another thing a lot of people take. And
Yep, lots of fluids. Uh, I sound like a NyQuil commercial. Anyway, yeah. So, hopefully you guys have a lot that you want to talk about, because I'm not sure how long my voice will last through this, but it is
yeah,
what it is.
I came up with a couple of things over the last couple of weeks, and
Oh,
we'll
beautiful.
talk about when we get a few people on. And
Yeah,
uh, now, Bill, you're also into 3D printers.
hmm yep. I 3D print a lot of stuff.
Okay,
Yep.
got one that's a favorite.
Oh, yeah, the one I don't own. Um,
Well, isn't that always the case?
yeah. Um, this new Bamboo Labs printer is supposed to be amazing.
The
And
HD2.
yeah, yeah, I think I would like one of those, or I would also like the Anycubic. I can't remember the model number for the Anycubic, but it's similar to the H2D. Um, multicolors, Core XY printing, etc.
Okay, now I know nothing about it. I barely know how to spell 3D.
I could help you
So,
with that.
what do you have to be aware of as a brand new person? I mean, well, brand new is I'm starting to learn 3D modeling program,
Um, which one?
SolidWorks.
Okay, you should be fine. Uh,
Is I got they got a special deal for, student or veteran type of cost, the full up cost. They like it.
yeah, They sure do. I don't know what the full up cost is now, but I know it's at least four figures.
Yeah.
Yeah. Um, the fortunate thing for me when I was experimenting with SolidWorks was I was also an adjunct at a college, so I got the educational version. Um, there is another way for makers to get a decent copy of SolidWorks. Um, the sure, it just fled my mind for a second. The EAA, the Experimental Aircraft Association, for those guys who've always wanted to build an airplane,
Okay.
they have a version of it. I think it's 75 bucks or something like that, or it's included with your membership to the Experimental Aircraft Association. And if I'm not mistaken, I think that's like 75 bucks a year membership. So
Okay.
it's free basically. Might even be 45. I'll look it up in a second. But they give you the software and course to learn it with, or you can go on Titans of CNC and watch their building blocks series, which is walk you through not only using um, SolidWorks, but also teach you how to use the CAM portion of it. So Titans of CNC is a great resource. Sometimes you'll see me wearing uh, one of his shirts to these things. Um,
Yeah, I just went out to YouTube and did a search and went through a couple of, the 3D projects, and
yeah,
it's definitely different.
yeah. Um, Titans of CNC gives away free curriculum to anybody. You can do a version in Fusion 360, SolidWorks, Mastercam. I'm not certain if they have one in um, what is it, NX, which is the bigger um, enterprise level software, but they have one in though at least those three, probably a few others, which takes you. Do I have one around? Anyway, all the projects use the same size piece of material, and it takes you start from finish to drawing it in that particular software and then laying out the toolpaths in that particular software and then machining it and inspecting it. And if yours comes in within the specified tolerance of your drawing, um, it will uh, you'll get a certificate.
Okay.
Okay, yeah. So free certification, which every engineering company, every place that aerospace, every place that machine shops and etc., they're accepting this as an entryway for you to get in to become a machinist for them or whatever. So if you're looking for a job, there it is. Uh, Pretty cool. And it gives
Uh,
that away to all the schools as a free curriculum if they want it.
how do you determine what filament you should use for what job?
Mm, well, you just buy one roll of everything and then experiment.
See what
No,
happens?
yeah. It depends on the use. Whether you want it to be water, if it has to go into water, you don't want to use a water soluble one. Um,
Some will
most,
flex
yeah,
more, some are more rigid.
yep. TPU, you can make like rubber wheels for your model cars out of that. It's very flexible, um, like rubber. Uh, ABS, PLA, PETG, those are all stronger. plastic. Most people are using PLA for most experiments. Um, and there's a version of PLA called lightweight PLA or foaming PLA, which we use a lot for model airplanes because it is so extremely light. So there's nylons, there's carbon filled, there's even balsa filled, or not balsa, but wood filled fibers wood and plastic that you can use.
Yeah, the little
Uh,
bit of reading that I've been doing, it's, obviously been there for a long time. And it's just amazing to me the capability that you now have in your shop.
yep. Uh, and keep talking. I'm sending Scott the link to get on while you guys are going. Scott was looking to get on. I didn't send out the link like I normally do today because I really, frankly, wasn't sure whether I was going to do a meeting.
Yeah, I'd looked earlier on the website and well, maybe you haven't recovered yet.
Yeah, and here we go. Found it. Here is the link. So hopefully Scott got that. Um, if not,
So
uh,
the bamboo model prints at a fairly rapid rate, or I imagine they're all just kind of like CNCs that you get some that are pretty slow and some that are a little faster. And
the current speed demon in the race is bamboo.
well, it is okay.
Yeah, that's the fastest. Unless Kurt knows of a faster printer. I think Kurt's got a Ender 3 like I have, I think. Is that right, Kurt?
Yeah, I got a couple of them, but I don't use them.
Yeah. Well,
I've got a filament. I had a filament, but I sold it to the kid next door because he wanted to learn how to use it. And I've got a resin one. I don't want to use it. I just don't feel up to figuring out how to use it.
well, send it here. No, no.
Yeah.
Yeah. Um, yeah, that's the whole thing. If you use it, it's amazing. I mean, you can, I make spinning tops. I like spinning tops. Go figure. Maybe it's an inception thing. But I, I wanted to see what shape spun the best before I cut it out of metal, which I never got to. But some of these are pretty good. I made a trumpet mouthpiece out of a plastic, and it actually plays. Uh,
Well, at our relative ages,
yep,
sometimes it's just because I want to and
yep,
I want to learn it.
yep. That's it exactly. Um, you know, there are many things that I've printed that were of utility that I could actually use them for something. Um, and you could get them any other way. Um, but what I like is I could come up with an idea for something, design it, print it, start playing with it, and say, "Wow, that's really great." And I could send you an email, and it's in your inbox, and you can start printing it now. And as lot, however, whatever the time is it takes to print it, it's like the transporter without the transport. We got the
Yeah.
digital, so you just have to have a replicator on your,
Well, a
yeah,
few years ago, I was talking with a guy that he was working with a outfit in the big town around me, and there was an additive CNC machine. They'd
yep.
weld up and then grind it and then, just build it. And I said, okay. And this has been a few years ago. I said, what's the application?
Yep.
And he said, well, they went from everything from Y stock parts for even automobile parts or whatever, is that you'll be able to say, hey, I need this part and go down here to pick it up, it'll be printed out for you.
Yep.
And then where it really hit home with me, seeing your background image there, was they said for the space intent of, okay, all of a sudden you break apart and you're on the moon or Mars, you can't get a replacement part. But if I have a machine to create one, I can send you a file to create it,
Exactly.
like you had just said.
Yep.
And I go, that opens up a lot of possibility.
Yeah, you think about it. You could only fly to, let's say, Mars every 2 years
Yeah.
because the distance is too great otherwise. You have to wait for the two planets to get kind of in sync. And if you had to wait 2 years for a replacement part, to your oxygen generator, let's say.
You might not make it.
Yeah, exactly. Yeah. So, pretty cool technology. Um, when you marry the power of laser cutting with the power of CNC routing or milling, and then add in 3D printing to the mix, you can make almost anything. Particularly if you also have a metal 3D printer at your disposal. But um, getting back to your original question, now we're what's the big dream? Uh, if you don't have something that you want to make, don't spend the money. Go down to the local library and borrow their 3D printer. Um,
Right.
I mean, our library has the 3D printer set up, and across town from there, there's an even bigger library that has a 3D printer and a laser cutter set up. None of them have routers because they're loud, but the point is you can get your feet wet before you spend the money. The Bamboo Labs is the most expensive printer. Let me take that. Let me walk that back. Um, Hobby grade. They're one of the more expensive printers. Um, I think if you got it with a 4-color printer, in other words, you can print in 4 different colors in the same machine at the same time. The new one is about $1,500 or $2,000.
Yeah, I see the new one. They've got it out there on their site now for about 2,400.
Oh, it's even worse. Okay. Uh, yeah,
Prices are
uh,
going up.
yeah. But if you need that, you know, it's not hard to justify, uh, using it for something. Um,
And what I find is after I print one thing or mill one thing, it leads to the next thing that you
yeah,
didn't even anticipate.
yeah. While you're thinking of that, I'm gonna see if I can find something here to show you uh, a use for it that many people never thought of. But this may take a minute because I gotta go back through the YouTube creators' videos to find the one I'm talking about. Um,
Even on Bamboo Labs has a video
mhm.
on, okay, what do you create?
Yeah.
And they had a couple things on there that I would have never conceived of.
Oh, excuse me. Such as?
Well, they made a tennis shoe.
Yep.
And I go, what? What? And then there's another person on there that made a bike helmet. Just different cushioning in the custom bicycle seats. And I thought, okay, that goes beyond just hard plastic.
Yeah. Yep. Um,
So they do have metal 3D printers.
they do. If you want to take out a mortgage, yeah, they do.
So how do
Uh,
they make the filament? Say you want to make something out of steel, they just got like a steel wire type
it
filament.
I've not seen any that use a filament. What they do is they use powder. So there's several different kinds of 3D printing. This would be selective laser sintering, SLS. So they got a little laser on the gantry instead of a hot end filament extruder. And they have a bin full of stainless steel powder, for instance. Okay. And the laser would come along and it would fire over the area in that bed that is equivalent to one slice of this part. You know how in a 3D model is sliced up into lots of little wafers, and they build it. So it prints the first one, a wiper comes along, pushes a pile of fresh powder over the top of it, because the table moved, shoots the next layer, pushes the powder over it, repeat over and over and over again. When you're all done printing, you vacuum the powder into a bin so that you can reuse it and take out your 3D part, which is a 3D metal object. But it's very fragile at this point. You have to then put it into an oven, and then that cooks the binder away, and it forms a solid that is then as strong as normal stainless steel. But the point is, once you get to that point, you have your solid 3D object out of metal. I hope that made sense.
Yeah, it does. I was
Space,
thinking it would be something like what do you call it? Resin printer, 3D
yeah,
resin printer.
yeah. There is a wire, now that I'm thinking about it, there is a wire welder type robot that feeds a wire, just like MIG or TIG or whatever.
Mm-hmm.
It's on the end of the robot, and there's a turntable that spins the part around 360, and this thing just goes and builds it up a layer at a time. SpaceX and some other folks are using metal 3D printing to make rocket engines.
I had seen a video on that several years ago where they were welding a bead around, and they'd come in, they'd grind it flat for the next one at that time or that particular machine.
Mm-hmm. Yep. All right. I found the thing that I wanted to show you. Here we are. Share. This is a guy that I really enjoy watching his videos. This one was from a few years ago when he first started doing this. When you can see the screen.
I can see it.
Okay. So he's using a 3D printer. We don't need to listen to that. I sped this up, by the way. So what he's printing is a mold for a nose cone of a jet.
So now I have the two pieces. First one, and this is the nose. And as you can see in the windows here, we have some work to do. I have to add some sparkle, some sanding, because we had like 2 dimensions picture, and it was really hard to construct, especially the windows, because the windows are straight, especially the front 2 windows. They are not curved with the fuselage, they are really straight windows, except the one on the sides. And so my friend Ralph, he really did his best, and they look amazing. He got the exact shape, and so but he couldn't avoid these because they're really hard to do. And so we thought we can do some sparkle in here, some
I'm gonna go forward to where he gets further along in the process. And then a little further.
But
So he gets to the point where he's got a fiberglass mold. We've all seen people make like Corvette replacements or whatever, fiberglass mold. But this is what he did with his 3D printer on a large scale. And then after he got the mold, prepared like normal, he laid in carbon fiber and resin and built it up a bit at a time, and more layers, more resin.
anyways, this is the simple way
So,
I think before, and it's hard to do, but I think
so
it's good.
there's
Fine, I
the
think I need
finished
I'm not
top
old.
portion. So, this is
Thanks
just
again,
something.
Banggood, for sending me this 3D
He
printer.
did.
Is really, really good. I'm very happy with it. And so for
So-
my next project that I will
Anyway, that's one example. Now this guy did that video 5 years ago when he first started that was the first thing he ever molded. And I'm going to show you what he's up to today, if you don't mind.
Absolutely.
This was the latest. Yeah, here it is. This is the latest thing that he used 3D printing, etc. for. And let's see, I'm not sharing, am I?
No. Oh, jeez.
So
Now let's see him actually lift off.
I'm not sure it's got quite that much power, but so he built this for Tyler Perry. Tyler Perry, the actor and director with a massive studio down in Atlanta that does all sorts of things. Anyway, there are pictures of him putting in the electronics to this thing, and all sorts of things. There's like 5 or 6 series where he's going through how he installed the landing gear, how he did everything on this gigundo plane. And it's all from techniques that he learned. Oh yeah, you got to see this coming out the door. Let's see, where is it? Right about here. He had to take off the wingtips to get this out of the barn door.
Wow.
where they built this thing. But
There in the back, I see it's not his first.
no, Tyler has had this guy building planes for him for like the last 2 years, and this is just the latest one. This is the 7779X Dreamliner, I believe they call it. Let me see if he's about to fly it. Yeah, all right. I'm gonna just let the video play for a few more seconds.
is amazing. The brakes are amazing and the landing gear is great. Honestly, we're so proud of this. Just seeing it doing that turn on the runway. Unfortunately, the turn radius is not so much, but seeing it turning, it looks so scaled. The next and final step is for it to fly good, and yeah, fingers crossed. The excitement is building up day after day, especially when it comes to programming and wiring and just putting it together for the first time. I lose sleep over that. Anyways, there is still a lot to do on this plane. Like, we made everything ready for it to fly, but there are still so many small details. There are no lights on it. There are a lot of small things that we will work on, but after the maiden flight. So we are hoping to get it ready by tomorrow for the maiden flight. And so wish us luck. Tyler is getting ready as well to fly this thing because he is the pilot. We did our job and the rest is on him. So no pressure, but I know that he got it just like any other plane. And so stay tuned, wish us luck again, and we'll see you guys very soon, hopefully next week. All right.
Now, I just wanted to make it clear, Tyler Perry, at his estate, those two buildings that we just saw, those are his RC buildings. The big hangar, that runway, that's his private runway for his models. He's got another spot where he takes off his full scale helicopter where he's, in it, etc. But his place looks like Versailles. The long, the big gardens, the whole 9 yards. And he's got this guy building him, not just that guy, but several modelers. He doesn't have the time to do it himself anymore, but he does have the money to have it done by the best modelers in the world.
Wow.
There's another video where they show the CNC router that was used to make the fuselage sections, and if I can find that, I'll show that because it's related. Yeah.
I was involved. I was involved with some RC airplanes back in the early 70s.
Yeah.
Things have come along a little.
Yes, they have. The telemetry, the electronics that he has in these planes stagger the mind. And he likes big jets. I like big jets, and I cannot. Anyway, yeah. So
Wow.
yeah, some of the stuff that they've built with the 3D printer, I found this guy during the pandemic. His videos during the pandemic, and I was thinking, wow, what a great way to build these things, and it gave me a practical use for the 3D printer. But his is a much larger printer than mine is currently. But even so, with the Ender 3, you can build up your mold in sections. Just print those sections and glue them together like he did. And you can.
Do they have some high temp? Well, of course, that's counterproductive to what the machine runs like. So if you were doing a high temperature mold, you'd want to create it and then cast it in a casting type material. So you still get there. I'm just thinking out loud.
A high temp mold for like injection molding.
Or like casting pewter.
I think you'd come. I think I would do it the reverse. I would print out the object that you want to make in pewter, but I would print it out slightly oversized by 1 or 2%. I'd have to look in the machinery's handbook to find the actual figure to use for pewter. But so you create. This is easier to explain. So
I think I know what you're after.
You create the 3D object that you want, slightly bigger. Now this is an exaggeration. Slightly bigger than the finished object that you want.
Yeah, that's a little more than 1 or 2%.
Yeah, but you get the idea. You could do investment casting from that, or you could do sand casting. Depends on what the level of finish you want. So what you do is you take this and simplest way I've seen, you could dip it in drywall spackle. Okay, and then you put a sprue. You know what a sprue is?
Yeah.
Do you?
Yeah.
Okay. It's a piece of material that will lead the hot metal to the part. And so you glue a couple of sprues on there. So let's say you were printing it this way or something. You glue one here and one here going down into the part. And when you go to pour this metal, okay, you've got this protective coating around it of the drywall paste that's all dried, and you put this into sand all around it. Just regular playground sand will work. You don't have to do the other kind where you're packing the sand and stuff. But
Well,
you
the
put it
Delft
in,
play.
right. You put it in there, you get it all set, and you put like a little, you know, hole in the top of the sprue so that the hot metal can get to the foam that the sprue's made out of, or whatever material it is. You pour it into one side, and it goes down and it fills up the mold. And when you get full, it melts up through the other side, the exhaust. So you've poured this whole thing inside of that mold. You let it cool, dump the sand, take the part out, spray it down with a hose. All the gunk comes off of it, and you get a smooth, finished part out of your pewter.
I was playing around with different ideas of like doing a pewter or a cast pewter mold or item
Yep.
and then inlaying that into wood.
Yep.
Yeah, a lot of things of what if.
Yeah. I know you, Milo. The minute you get your hands on these tools, you'll come up with ways that none of us thought of, and they'll be amazing, and they'll work, and they'll be replicatable. So, you
There you
know,
go.
I'm just, trying to give you some of the basics of what I've heard. I haven't done all of these things, but I sure watch and get to know how. Yep.
Well, have you ever, I'm asking a question I know the answer to. Did you know there's a way to calculate volume in Vetric?
I knew, but you can tell us all.
Yeah, it's a key combination. Apparently, I've been reading different forums and whatnot,
Hmm.
and it's a pretty common question of how can I calculate the volume of this design that I cut? Well, it's been there for at least since 22.
Yep.
And I'd never heard of it. Control, Shift, Alt, and V. And then if you play around with the zero plane and you place the zero plane in the proper position, it calculates how many cubic inches the cut requires. And it's pretty straightforward.
Control Shift Alt and V.
Yeah. Do you want me to throw up an example? Because there's a couple little gotchas. I'm trying to come up with an instruction sheet right now. And, but I got to thinking, okay, I've read it a few times. I have never done epoxy inlays.
Hmm.
But I thought, okay, until a person has done it enough to get a feel for it, I've heard of pouring rice in there and then scraping off the rice and measuring it or sand or whatever. Well, it's already in the program.
Hmm.
And let's see, sharing is not turned on.
It should be. Hang on. Allow. Let me make sure that it's. Oh, sorry. I think I hit something by accident.
Oh, that's all right.
All right. You're all set.
Okay, let's go share. Okay, let's take this off over to here. Let's get rid of all this crap I was playing around earlier. We'll start with a fresh start. Okay, 10 by 10. And we'll put let's do a 5 by 5 square in the middle. Now, here you either have to have a pre-made model because they calculate the cubic inch of a 3D object. So if you're in VCarve, if you import it in a model, you can calculate the cubic inches of that. In Aspire, of course, you can make your own models. And so you can create whatever you want. If you do a flat plane model here, let's go 1 inch for ease of calculation. And so 5 by 5 by 1 be what, 25 cubic inches. If you, let's get you guys drug out of the way here. Control Shift Alt V. Oops, apply. Oh, base height. I'm sorry. 1 inch. Apply. There we go. And if you click this, Control Shift Alt and then V, and there it's at 24.85 cubic inches.
Pretty amazing.
And now if we take and make this a subtract, and we'll do a zero plane on here. We'll create a component. Oops. Add a zero plane. And so you get it caught in here.
Mm-hmm.
Control Shift Alt V. And so you got your negative. And that's all there really is to it. Now, if you get a little more application here, let's take and put in about a 6-inch circle. And let's put some text on here. And let's create this on an arc. Oops, on an arc. Oops, I clicked something too many times here. Back up. There we go. I think I hit the wrong button.
Mm-hmm.
Text on the other side. Come on. Let's go here and let's take about a 3/8 of an inch offset on that. Come on. I'm clicking too fast here.
It's a live demonstration bias.
Of course.
Mm-hmm.
And trying to offset that. I thought I could do this here. 0.3. Oh, my num lock must be off. I get it. Okay, now let's take and do a V-carve on that. Preview that. Now you can't, this is not a 3D model. This is just a preview, so you cannot measure the volume. So if you come up here and you create a component from the toolpath preview, now you have a 3D model of your toolpath preview.
Mm-hmm.
So now if you take, oops, click that with a Control Shift Alt V, this thing is saying it's 99.5 cubic inches. It's measuring the whole thing.
Yeah.
Minus whatever this is. Well, you don't want to think that hard. So if you use a zero plane, and the trick is you have to adjust the height of the zero plane to the surface. Come on. And as you change this, there you see that slight coloration difference?
Yep.
Since the model was 1 inch on the text, do a -1 inch on the zero plane. And now when you zoom in, you'll see this zero plane is right at the surface of this model. Now when you do Control Shift Alt V, oops, Control Z, come on. Click once, Control Shift Alt V. You got minus 0.4 cubic inches to fill up those letters.
So you make a half ounce of epoxy.
And if you want to do
Or
the math
cubic
right
inches,
here,
excuse me.
yeah, right here in the Windows calculator, they have a volume calculator in there. And we'll go cubic, where the heck are you? Cubic inches. You can go to teaspoons if you want. So you just type in your 0.407. And it's 1.35 teaspoons. Or you can do fluid ounces. Let's go here to fluid ounces. So a quarter of an ounce would fill that up. Now, if we come back here and we add a little more to this, since you already have a 3D model of the letters, you can just create a, let's go half an inch, and we'll subtract it. Now let's bring this up and apply that. And then we'll close it. And now, when we take and Control Shift Alt V, now we're up to 14.5 cubic inches to fill that void along with the letters. And if that's all you wanted to do, there we'll go 14.5138. So you got about 8 ounces, or about a cup. You know, the guys that do this every day, they've got the advantage. They know just through experience. Well, shoot, I don't do it enough to have any kind of a feel for it. If you add a little more here, let's put an image in there. And let's put in about 3/8 of an inch here. So it'll be a little bit, we did a 1/2 inch deep void. We'll do a 3/8 inch star. And on these things, if you haven't done this very much, you can see where the star has a little bit of a sway back.
Mm-hmm.
That's component number 3. You preserve the internal corners. Now you got a nice shaped star. Control Shift Alt V. Now it's taken out the material that filled in and readjusted the total cubic inches now of the complete piece. So I thought that's a pretty slick little deal for having been there for 3 years now, or at least 3 years.
Yeah,
And
for everybody doing this, for those folks doing resin inlays, this is totally valuable.
Yeah. Well, and same thing, like we were talking with, if you were pouring a mold like we were talking about in a sand cast,
Mm-hmm.
you know, this type of thing, limited as it could be to at least this type of application, or if I wanted to cast letters and then later inlay them into this surface, now I know how much pewter I'm going to need to melt down to pour those things.
Yep.
But yeah, I thought it was pretty slick when I stumbled across this.
Definitely is. Kurt just put something in the comments about uh, different units of measure. See what we got.
Oh yeah, I've seen that before, Kurt. I only seen that here less than a couple weeks ago because I was working with a person that was doing everything in metric, and my brain don't convert metric
Right,
to inches with ease.
right. Neither do I.
Save my voice, Kurt. Read it to him or talk about it.
Okay, essentially, if you import a product and it's listed in metric and you want to work in inches, imperial, you go into the dimension box, either the width or the height, either one, put your cursor to the farthest right side, to the right, farthest right to the numbers, and type in asterisk I equals, and it'll instantly convert it to imperial.
Here, let me
So,
pop it up so we can show it.
well,
Maybe.
yeah, if you can pop it up there, yeah.
Let's go back over here. And dimension. So if we put it
Yeah,
in here,
yeah, your dimension, like length and the width.
oh, shoot, I just changed that to metric because isn't metric asterisk M?
So you got, okay, yeah, you can do that either way.
Wow, that's pretty
You got a
slick.
radius there. Yeah,
Because I changed this from 6 inches to metric, then multiply I, yeah, back to 6 inches.
yeah,
I
there
didn't
you go.
realize you could do that in any of
Dimension
those
box.
boxes.
Powerful using
Oh,
tips here. Yeah. There's
well, and
just
the
so much
worst,
in this software.
There's a bunch of tips in there. I don't remember them all.
Yeah.
When I was doing a lot of work before, I used a bunch of them. There's a bunch of these little hidden things, and there's a sheet somewhere that has all that, but I can't find that either.
well, I went up to the help file and looked for the keyboard shortcuts,
Yep.
and I could
Okay,
not find anything that had the control or anything for volume. I did a search on the entire document for volume and nothing came up.
yeah, there's something about that. I think that if they would publish something somewhere for all that, it'd be helpful. But some of those things you just have to know.
Yeah, stumble upon it, and I've been
Yeah,
messing with this now for good grief, coming up on 9 years.
Yeah. A
yeah,
lot of
And I'm a
lot
new
of
guy.
they used to give a lot of the these shortcuts at the users group meetings that they would have. Particularly when James
James
was
Booth.
attending them. Thank you. James Booth was attending them. He was just a wellspring of information. Somebody printed a manual too at one point. I've got copies of that back from second or third users meeting that had a lot of this stuff in there.
I did run across one other thing here that caught me. It's the last pass. There's a lot more people that are starting to do full pass depth cutting. Here, let's clean this up a little bit. Shut all that off. And if you cut this with a profile, and let's say it's only half an inch deep, and I want to do that with a single pass. And then say, well, I'd like to do a last pass to clean up the when the bit enters, it'll have a vertical line there. And then as it relaxes from spinning, it'll leave a registration mark. Or if you're doing, when you want to do just a last pass with about a 6 or 10 thousandths to come inside, if you do a last pass, let's do something big here so it's easy to see. And let's go back over here. Let's finish this up. Reset. Even though I selected a last pass, it doesn't do it.
Mm.
With a single pass. Now, if you have two passes, there is your last pass. It moved inside on the last pass to cut it. You have to have more than one pass in order to get this last pass.
Yep.
Because it uses, when I sent this up to Vetric, I thought it was a mistake. Because I said, hey, more and more people are doing a full depth cut, but they want to have a final cleanup pass where it's just skimming the side to get rid of any chatter that may have been there so that the bit isn't bouncing off the walls.
Yep.
And they said, well, we said it was a separate last pass. I go, yeah, and well, that means you have to have more than one. I go, okay, I would have never in my lifetime gotten that out of that verbiage.
Yeah.
And I said, in the help file, it does not state that you have to have more than one pass. I said, so just my recommendation from somebody who doesn't know the King's English is that that's not very helpful.
Yeah. Made perfect sense to the programmer, but not to the user.
Yeah. Well, what I have also found that right here, oops, let me show you how I got there. This edit passes. This set last pass thickness. You go a whole bunch of zeros and a one, and you reduce this down to one pass. You'll see here where it says a half an inch and a half an inch. There's two passes there, even though I have it down here as one. This one here sets another one.
So you end up with 3?
No, well, I only took it down to one.
Okay.
But now here you see where I do have a last pass. They're at the same depth in all practical terms. And so now you'll have a single pass go around and then another one to clean it up as it comes inside.
Okay. Yeah, we call them finish passes or spring passes.
Yeah.
What version is this?
This is 12.
Okay.
And I think it's been the same thing for quite a while.
Yeah, I was just looking in 10 and looking for it in 10 and I'm doing it I'm looking in 2D profile toolpath. And I don't see
Oh, the last pass?
yeah.
How about advanced options?
Okay.
Because I think
I
when
don't
you
see
take this, when you take the advanced options check mark off, it doesn't show you the last pass.
I'm pretty sure it was in 11 at least.
Okay, I'm looking in toolpath, 2D profile toolpath. And I don't even see the option to click.
You want to share your screen? We can.
Oh, there it is. There it is. Show advanced. Okay. Now I got it. Thank you.
Yep.
Thank you.
Yeah, that
Do
was
separate last pass.
something that snuck up on me because I was cutting with an 1/8 inch bit down through 7/8 inch hard maple. And I was getting a lot
Yeah.
of bit chatter
Yep.
as I was going down through there. I thought, okay, I'll clean up the last pass. Well, if you have multiple passes, it takes the last pass depth and moves in. So that last 1/8 of an inch, or let's say it would take that last 1/8 of an inch and move in. It didn't go all the way down and then move over to take a full wall cut. So if you're taking 1/4 inch passes, it'll do let's say on 3/4 inch, it'll do 1/2 an inch, move in, and then the last 1/4 inch around. And then you still leave a tool registration mark just on the lower portion of it. And what I was after was trying to do the entire depth, one last skim pass to clean it up.
Do you use lead ins?
I did do that. It got rid of the vertical line.
Yep.
You know, the lead in took care of that. But even on a lead in with a last pass, they don't do the lead in.
Yeah.
Did you see that?
No, I had looked at it that closely recently, but yeah, it doesn't.
It was kind of a bizarre thing. I brought this up to Vetric here a while ago. Let's see, where are we at? Oh, leads down here. Lead out. That should take care of it, I think. Let's do a really big one
Would you really want your lead out to go outside like that?
Well, let's say you wanted to keep the inside.
Yeah.
You know, and you had tabs in here to keep it from falling apart.
Okay.
But let's do a long son of a gun so we can see it better. And let's do multiple passes here so we can see it. And you like here does what you would expect it all the way down. If you put in a separate last pass, and we'll reverse the direction even. Right over here. Here are your lead ins for the starting off and then coming in. But this last pass moves in and it comes down and does your ramp on the piece. So whatever you tried to get away from, you put right back in there again when you did a last pass. Let's take these ramps out because that kind of makes it harder to see. And so now on that last pass here, you got the bit coming down the side of the part and you leave that bit registration mark in there while trying to keep it away from it by doing the lead in and lead out. And when I asked Vetric about that, I said, is this intentional? I said, I can't see how it could be. But they looked at me really funny and I says, no, take a look. The last pass does not do a lead in, which kind of defeats the purpose.
Yeah. They'll fix it in 12.5.
Yeah, 13, 14.
Yeah. So
Well, the last pass is only going to be about 3 or 4 thousandths, isn't it?
Yeah.
but you still see the line.
Yeah.
So it comes straight in and then goes. It doesn't roll ramp in.
Right.
Oh,
And those inserts that I've been messing with that I've shown you guys before, is it was leaving a doggone registration mark on there, plus all the bit chatter. And so I went in there and I finally made my own last pass with, a lead in and lead out vector. And then I can also control the overlap that way as well. And if you can't beat them one way, do it another.
One of the tool paths that I was always uh, wanting, especially when I started doing aluminum, was the helix in plunge. And so you don't break the bit. You just take a little bit in the ramp. You can't really do that with the ramp command very well because they've got zigzag ramp, but they don't really have.
Oh, they got a spiral now.
Oh yeah, okay, yeah. It's been a while since I've been out the machine. I've been sick all winter.
Oh yeah, don't doubt that a bit. Here,
Yeah,
let's take these ramps off of here. The only reason I am aware
yeah,
is because I use it a lot.
yeah,
Just take the last pass off right here, this spiral.
yeah.
This
There
is
you
how
go.
I was also cutting internal threads before they put the threading toolpath on there.
Yeah,
And here you can see it swinging around, and then one last pass. Before they did the threading toolpath, I would take and change the pass depth here to the thread pitch I was after.
yeah.
But yeah, this does a nice job.
How
It's
fine can you set it?
This here is set by the pass depth.
Hmm.
So if you set it to 0.06 and we're going a half an inch deep,
Yep.
and see, this is how I also do test cuts on a machine when I'm doing a calibration
Hmm.
and setting the acceleration and deceleration rates and the transitions. If you get a really tight spiral, like a 1/4 inch hole
Yep.
with a slightly smaller, it'll either shake itself to death or it'll do a nice controlled descent. And this is how I set that up for that type of test.
Hmm.
And here back in 2018, I think, or 19, was at the Chicago user group. They had mentioned where they put in a vertical helical arc to where you can get G2s and G3s vertically,
Hmm.
where it used to be only G1s, short straight line segments. Now, a lot of the post processors have this will cut as quarter arcs and it gives a lot smoother cut going down.
Hmm.
The machine doesn't try to shake itself.
Well, good. I haven't used that feature in a while, so uh, it's nice to know that they continue the development.
Yeah, they
Uh,
don't, like a lot of companies, the people that write it are the worst ones to advertise the improvement. Then
yep.
you go, well, yeah, just everybody knows that. Because I'm waiting for them to put in a horizontal helical toolpath. Right now, if I do this on the rotary, it's all G1s. It's not quarter arcs.
Gotcha.
And then again, it'd be for smoothness of cut. Because I asked them about it and they said, why would you want that? And I said, well, why would you want this flat? And they said, okay, fair enough. I said, the same reason I would want this, I would want it on a rotary. Well, we'll consider that for future enhancement. I think is the normal response.
Yep. Well, you are definitely a power user. I used to be. I don't have nearly as many use cases as you do. Once I got into production work, you didn't use as much of it.
Yeah.
But when it was creative, oh my goodness, I was like, "Oh, look what I can do!" Just
Yep.
experimenting just because you could.
And it was driving me crazy is the bit deflection testing that I was doing for the bit manufacturer. We've got some tests that people that are in denial that a bit will deflect and therefore make wild ass cuts on your vertical walls that everybody complains about, but they blame the wrong thing.
Yeah.
Yes, the machine is certainly to blame at times, but there are times where you can't stop it, like from the bit deflection. And so how do you clean it up? But by these offsets or changing direction from a climb cut to a conventional cut, throw the bad cut on the waste side. It doesn't matter if you're only doing one, but I did over 400 inserts. The first 3 or 4, I said, I don't want to have to work with that problem. I want that out of my cut. And so, yeah, it took me about 5 to go, oh, whoops, I should have gone the other way. And once I had it done, well, the next 300 were just fine. Got boring, but at least I didn't have to sit there and clean it up by some other method.
Just an example of what you're talking about. There's a video. This is in metal, so just assume it's wood. Because same thing happens. Wood is the same as metal. Just happens at a different frequency. Here we go.
Yep, I've seen that before.
If you notice, the bit is wobbling, and now the tip is gone. And oh, imagine that.
Oh yeah.
And you can see that all the chatter marks on the side of the metal.
Let's back up a second here. If you've been around my channel for a while,
Yeah.
you know that I've looked at chatter.
This is the helix I'm talking about
audio
wanting
spectrum analysis.
better
This is a
control
really
of.
easy, low-cost
yeah.
way to.
All right.
Anyway, you get the idea. Let's see.
I actually caught on video an 1/8 of an inch bit coming apart. Is that it was in hard maple, and I was doing a spiral ramp in.
Yep.
And it didn't make it halfway around. And as I slowed down the video to watch it again, you could see the bit starting to deflect out further and further and further, got halfway around. And I mean, it was sticking out there like that before it finally snapped off.
Yep.
And the bit manufacturer, he goes, I think I better redesign that bit. It should have not done that.
Yeah.
And he said, boy, that's hardwood. He said, but you weren't down very far. And the best part is when it was spiral ramping down, you could see how far off it went from the intended path.
Yeah.
And it wasn't that deep into the material.
There's a lot of force involved, and bits are long levers, with a fixed point at the end. So it's very easy for the machine to overpower the bit, snap it.
Yeah. Well, I started using a 3/16 end mill, and it did a massive difference in the quality of the cut from an 1/8 inch bit. A little more waste, but my problem is that I'm using the cutout parts for other parts. So I didn't want to get, a 1/4 inch bit if I could get away with it, because then that made my cutout part unusable for the next project. And the 3/16 I was able to make it work, but the cut difference, unbelievable, from a 1/8 inch bit to a 3/16 inch bit.
Mhm. I tend to think when you're removing a lot of material, if you can use a bigger bit, you're generally better off doing so, and then using a smaller bit just to clean up around the edges. It's you're able to go deeper and faster with the bigger bit without the worry that it's going to break as often. But there are limits, obviously.
Yeah.
When you're doing a complex cut where the bit doesn't actually fit the area that you're going to cut, that's pretty stupid to do it that way. So um, everybody's always cutting with a 1/4 inch bit because that's the first bit that everybody got. Um, Back in the day when CNC was new and everybody was talking about 1/4 inch bits. But if you go up to the next size bit, a 3/8 bit, yeah, I did the math right, didn't I?
Yeah.
Thank you. Sometimes you got to check these things. You go up to a 3/8 inch bit, you can move more material. It's a stronger bit, and they don't generally cost anymore because 3/8 is a common size in industry versus 1/4 inch.
Well, even the 3/16
Yep.
bit that I used, I did not expect it to be that much different than an 1/8 inch bit.
Yep.
But the voodoo math that this bit manufacturer, he punching
Yeah.
away on his calculator, he says, well, that bit is 3 times stronger than an 1/8 inch bit.
Yep.
And I go, it ain't 3 times bigger? He said, yep,
Yep.
doesn't matter.
Yep.
And
Yeah.
then, the center core strength that they have, and whether it's a 2 flute or a 3 flute, there's so many variables. It's kind of
Yep.
like, okay, cut it and see what happens.
Yeah. Yep. So I don't know.
Yeah, the core
It's gonna.
diameter. Yeah, the core diameter of a 1/8 is almost no core in it when you get done sharpening it. When you get a
Yeah.
3/16, you got quite a bit of core in there.
Well, and the funny part is, until you really look at these doggone bits, some manufacturers cut a really deep flute because they're looking for chip extraction.
Yeah.
Well, then they
Yeah.
end up weakening it so bad because there isn't any center core left. And so, yeah, you go to buy a bit, unless you know what you're looking for, you can't go by the picture. But yeah, there's a lot of people manufacturing bits that I don't know why they cut them so deep. The flutes are really deep, and I thought, yeah, I know it's for chip extraction, but there's got to be a balance there because you're losing too much strength.
They wrap them, they take a bit and it's straight, and then they twist it around the axis. So I don't believe they're actually cutting it. That's actually a twist.
I thought it was cut because it's a
Well,
solid carbide bit.
They're ground.
yeah.
They
Well,
use.
they push them into a mold and it for the carbide. Yeah, you're right. But the high speed, I was thinking it's a little bit different. The high speed ones are twisted, but the carbides are stamped into a mold, then ground.
Oh, okay. And then ground. Yeah. So I've seen them
Yeah,
using diamond bit grinding wheels that are like,
right, right.
yeah, amazing. Uh,
Well, that one bit that I put up on here, it was a .028 diameter end mill with 5 flutes on the darn thing. I would have loved to have seen the machine actually grinding it, because you're talking the size of a lead pencil, of the
Yeah.
lead in the pencil. I thought, how in the world do they get that thing ground with any
Yeah, who
accuracy
can
at
see
all?
that? Yeah, who can see that small, let alone grind that thing?
Oh, I put it under one of these cheap little magnifiers, electronic magnifiers, and there is some science to that. And I thought, okay, I want to see the machine.
Yeah.
Yeah.
I
You get a little backlash on that, and you wouldn't have anything left.
I'm trying to find the video I saw from last year's IMTS show. Um, okay, here we go. Found it.
Bill, your memory isn't totally lost with your drugs keeping you vertical.
Yeah. Uh, multiple diamond wheels at the same time. I don't. You guys can see this, right?
Yeah.
Yeah. Apparently, I. Now, this has already been. The blank has already been made out of the carbide compressed or however they're making it before they cut it like this. But these machines are like $500,000, $1 million. Grinders.
I don't doubt that.
Yeah.
They
Let's
use air
see.
bearings and them things.
Well, and it kind of makes you wonder how they can sell the bits for the price they're getting for them.
Well, they make thousands of them or millions
Tens
of
of
it.
thousands, yeah.
Yeah. Shoot. I'm gonna just take the search offline while we continue to talk. But um,
But probably also, I've never seen anybody yet, unless it's a really high end bit, that they say it isn't worth sharpening the smaller bits.
Well, isn't the smaller bits, isn't the last, excuse me, the shank, isn't that regular steel and the last bit is soldered on?
Well, some are, but I
Yeah,
know the
okay.
ones that I'm dealing with on this bit manufacturer, they're a solid carbide.
Solid, okay.
Yeah. Because you drop them on the concrete once and that's about it.
okay, I think I found one. Uh, not sure what the volume is going to be like or whether this is worth watching, but here we go. This is
Now I can see it. That is an odd looking blank.
It's
yeah,
like a
I'm not.
burr.
Yeah. Oh, it is.
Oh, knurling.
Yeah, it's a burr. Yeah.
Okay. Well, I thought I had it.
You see where they
Well,
welded it right there.
Yeah.
You can
interesting
see
to
where
see it anyway.
Yeah.
yeah.
If I find it in the next few seconds, you know how this is. We're doing it on the fly.
Yeah.
But
Even the solid carbide bits, they may be solid carbide, but the upper shank is a little bit softer material. It might be a mixture. I don't recall exactly anymore, but they're soft enough they can actually bend, whereas closer to the end where the cutter is, they actually break.
Shatter, yeah.
yeah, I know I've seen these videos before because I was curious how do they make these? What goes into it? But finding it on the fly has always been interesting. Well, this might be it. About 18
Well, I
minutes.
worked in a tool shop years and years ago where they made bits and cut bits and all that. And Don Kirshner, he's one of the beta testers for Vectric. He's down in Indiana. He's actually got a, a, a tool grinding shop where he grinds cutters.
Yeah. And mill production. Here we go. The Schneeberger. Okay, these are the I think they're Swiss Schneeberger or German. I'm not sure. See if this is anything good before we look at it. Oh no, this was part of what that first video came from. It's only 29 seconds. All right. We'll watch it.
Yeah, I'd like to see it.
Get a shit.
Yep.
There she's coming.
So here goes. Apparently there's no sound. A little bit of how they programmed it.
There we go.
Anyway.
Pretty wide grinding wheel.
Yeah. And you could probably buy a new Tesla for what those wheels cost. Just about.
I'm guessing.
Yeah. I'm exaggerating, but yeah, they're not cheap. You really don't want to ding that wheel.
Oh, just for a quick off second, there's a Tormac for sale in the auction over here. Just for a little quick side note.
Yeah.
In the
Let me see if I
auction?
Yeah, let me see if I can find it real quick.
Well, I already own one, but if you guys are interested, feel free.
Oh, it's gone.
See?
Jesus. Didn't last long.
Yeah, that's like that laser cutter that was just down the road from me.
Yeah.
It was a Thunderbolt laser, never used.
Jeez.
And by the time I decided to call, it was already gone.
Yeah, then you can sit there on a machine for 6 months and never get a nibble.
Yep. Well, I can feel my voice starting to give.
Fade out. Call it a short night.
Yeah, I think maybe we ought to do that. Unless you guys want to continue, and I could just sit and listen. That would be cool
No, you
too.
need to go to bed. You need to go to bed. We don't need you sick.
No.
All right. Well,
It was still a good evening. Glad you lasted this long, Bill.
I am too. I think I was debating on whether to do it or not, and really, this is kind of one of the highlights of the week for me, getting to hear all the amazing things you guys are doing, and I appreciate you. I really do. If you would like to join us, go ahead, Kurt.
Well, yeah, I was just going to say that so when you let me off early tonight, I'm going to go figure out my steps per inch on my new CNC tonight.
All right.
Yeah, yeah, we expect to see a report when you get that going. Finally.
Yeah.
So
all right.
Thank you guys for coming. If you're listening to this and you would like to join us next week or any week thereafter, we put a link inside of the Facebook group. We do it Tuesdays at 7 p.m. Eastern time. Thank you guys for coming.
See you.
Bye.